Hi everyone. Today we are looking at lesson 2.4 on polynomials, multiplying a polynomial by a monomial. We're going to start by just multiplying monomials together. So just as a refresher, remember our algebra tiles. The dark ones are the positives and the whites are the negatives, or the non-colored ones are the negatives. And I want to remind you that these are actually sized intentionally. This distance here, this is 1 unit, and this is also 1 unit, okay? And then the X tiles are the same width, they're 1 unit in width, and they're X units in length, okay? Um, and of course, X is variable, it can be whatever we need it to be, but it's X. And the X squared tile is also X in one dimension and it's X in the other dimension, okay, which means the area, so the area of this is 1, and the area of this is 1 times x, which is x, and the area of this is x times x, which is x squared. Okay, so let's just remember that. And let's look at an example multiplying things using algebra tiles. So what we have set up here is the question for multiplying algebra tiles. And on the side here, there's an x and another x, and I have two x's. And along the top here, I have 3 negative x's, so we write that as negative 3x, okay? And then when so what we want to do now is we want to put the algebra tiles that fit in here. And the best way I've found to describe how you know what's going to go is there's a line that's going to come down here, and a line that's going to come down here, and a line that's going to come down here, and a line that's going to go across here, and a line that's going to go across here. And now what you want to do is fill those spaces with what fits. And you can see by looking at it that what fits there is going to be, this is going to be the x squared shape. And this is going to be the x squared shape. And this is going to be the x squared shape. So they're all going to be the x squared shape. Because if I tried to put anything else in there, I would have more dotted lines that I would need to put in than I have in my drawing. Did that make sense? I'm not sure. And then we need to decide, so we know the shape is going to be the x squared. And now we need to figure out whether these are going to be filled in or not. So what we do is we say, well, this one right here, this is a negative x times a positive x, which is a negative value. And this is also a negative value, and they're all going to be, this one here is negative times a positive, so it's also a negative. So the answer here is that negative x times x is negative x squared, and there are 6 of them. So 2x times negative 3x equals negative 6x squared. Okay? That was hopefully fairly straightforward. Let's do this symbolically now, okay? So when we're multiplying things, we have 2x times negative 3x. And when we multiply things, there's what's called the commutative property of multiplication, which means you can multiply, doesn't matter what order you multiply things in. So if I just drop the brackets first, this becomes 2 times x times negative 3 times x. And I can rearrange that so that it's 2 times negative 3 times x times x. And then I can multiply my 2 times negative 3 is negative 6, and x times x is x squared. All right, remembering your exponent rules and remembering that there is a little invisible 1 here. So we add those together. Okay, and that's it for multiplying monomials. There's one more thing to show you, just a more complicated example. All right. Um, it's just a more complicated example. So if I break this down into, this is 2 times x squared times y cubed times -4 times x times y, and then I rearrange them. This is 2 times -4 times x squared times x times y to the y cubed, sorry, times y. So 2 times -4 is -8, and then it's x cubed y to the 4. Okay, because again, there's a little invisible ones there. When there's not an exponent, there's an invisible one. Okay, so the thing that's different about this is that there's no such thing as like terms when you're multiplying things, because you're not adding them together. So they don't have to be the same thing. You're multiplying them, and it's okay. It works. All right. So I'd like you to pause the video here and do assignment 2.4.1, which is on the next page of your notes package. And then come back after you've done that, come back and do the next part of the lesson, because it will be so much easier if you've already done the practice on multiplying monomials. Okay, so pause the video and then come back. All right, let's take a look at multiplying a monomial, 2x, by a polynomial, which is 3x minus 4. And so you see on this side we have 2 x's, and here we have 3 x's and 4 negative 1, sorry, so that's 3x minus 4. And we can use the same technique of drawing all these little dotted lines and obviously you wouldn't, that one didn't work very well. You wouldn't keep doing these lines once you're comfortable with what you're doing, but for when you're learning, it's not a bad idea. These are not going where I want them to go. And then there's a dotted line along here and along here. Oops. Okay, so you can see that in here I've got an x squared space and an x squared space and an x squared space. And then this is an x space right here, because that's that little rectangle size. Okay, so I'm just going to fill in all my shapes first. And you can, of course, do this with the algebra tiles as well, you know, rather than drawing it. And there, you do need to be able to read these things, whether they're done with algebra tiles or done symbolically. But all right. Okay, so there are all my shapes, and now I need to decide which ones are positive and which ones are negative. So this one here, this is a positive times a positive, so that makes this positive. So I'm going to color it in with my little highlighter here. And this is also positive because it's a positive times a positive and a positive times a positive. And these are all my x squareds are in this case going to be positives. All right. And then over on the right here, I have this x shape is a -1 times a positive x, which is going to be negative. So these are all going to be negatives. So my answer here is I have 1, 2, 3, 4, 5, 6 x squareds, and they're positive x squareds, and minus 8x. So there's my answer. All right. Let's do this, your turn, right? So you can do this, pause the video and do this using algebra tiles, and then come back and see if you got it right. All right, I tried to make these really pretty for you, but holy moly, it took a long time to do those questions, so I'm just going to do this freehand now. So the shapes that I'm going to put there are going to be the x squared shapes, or m squared if you want to call them that, and then some m tiles here. And these are all going to be negative because they are all a positive times a negative. So all of them are going to be negatives. Okay, now since we're not in class, I'm just going to do something wrong here to show you. You can't put tiles like this because if you put the tiles like this, you would need to put a dotted line between them here, and you can't because it runs into this, okay? And similarly, I can't put X tiles here because if I put a dotted line, it has to go all the way, and it doesn't, okay? So if we were in class, and you were making this particular mistake, I would be able to see that that's what you were doing because it is something I see often. There we go. Okay, so let's finish this up. So we get another negative m and another negative m. All right, so our answer here is we have 6m squared and 1, 2, 3, 4, 9 minus 9 m's. All right. Okay, so there's another assignment for you to do in your textbook, section 2.4.2 in the textbook. Now that assignment is specifically using algebra tiles, and I really want you to go and do that with algebra tiles. And then come back again. There's one more part of this, doing multiplying, oh, actually two more, multiplying using an area model or a rectangle diagram. So go do the practice, check your answers, and then come on back, okay? All right, let's take a look at different ways of multiplying. So you want to see a super quick way to multiply 54 by 29. So what I'm going to do is I'm going to make a box, and I'm going to say that this distance up here is 54. So this piece is 50, and this piece is 4. So 50 plus 4 equals 54. And then along the left side here, this is 20, and this is 9, so my total is 29. All right? Now, 20 times 50. Well, 2 times 5 is 10, and then I have 2 more zeros, so that makes this 1,000. So it's 20 times 50 equals 10 and 2 zeros. This is 4 times 20, which is 8 and 1 0, 80. This is 50 times 9, which is 5 times 9 is 45, and then add the 0, so 450. And this one is just 4 times 9, which is 36. And then I just add them up. I go 1,000 plus 80 plus 450 plus 36. Add them all up, that's a 6. 8 and 8 is 16, carry 1 is 5, 1566. There's my total. Okay, that was kind of neat, wasn't it? I broke it up into chunks and I multiplied the chunks. So I can do the same thing with a polynomial. So if what I have for my polynomial is 2x times 3x minus 4, I can do this. I can say that this side is 2x and this side is 3x and minus 4. And the size that I make things really doesn't matter. I do try and make it like, you know, if this is 2 and this is 3, it's sort of a little bit bigger than the 2x, but it really doesn't matter in terms of getting your results. Just sometimes if the diagram makes more sense to you, then that's a good thing. All right, so in this box, I get 2x times 3x, which if you've done all the practice work, should be pretty straightforward. That's 6x squared. And 2x times negative 4 equals negative 8x. So my answer is 6x squared minus 8x. Okay, your turn. Go ahead and try this using a rectangle. Oh, sorry, let me just talk about a rectangle diagram and an area model. They are exactly the same, except that if you have a negative in it, like here, you have to call it a rectangle diagram because you can't have a negative area. But if it was +4, we could call the same thing an area model. It's the same thing. All right? All right, go ahead and try this, your turn, and then come back and see how you did. Okay, did you get the answer right? I hope you did. Okay, so now there's some more practice on the next page working with area models and diagrams. And so go do that and then come back and we're going to do this multiplying symbolically. Okay, because that's of course how you do this once you're past grade 9. But it's important to understand why things work. Okay, so pause the video and then come on back. All right, let's do some multiplying symbolically. So just to show you that you get the same answer doing it different ways, this 2 plus 4 plus 2 times 1 plus 4, the old way the way you would do this following order of operations is you would do what's inside the brackets first. So this becomes 2 times 5, which is 10, right? But I want to show you we could do it another way. Oops, I was going to put my camera up here. There we go. So when I have 2 times 1 plus 4, it means that I have a 1 plus 4 and I have another 1 plus 4. Okay? So I'm just going to rip that. I think I did this in class when we were doing the review at the beginning of the year, but I'm not sure. So I'll do it again. So here I've got a 1 plus 4 and I have another 1 plus 4, right? And I have both of them. I want to know how much of everything I have. So what if I tear this one like this and I split that one like that and then I regroup them and I do this instead. So I've got 2 1s and I've got 2 4s. So the way we would do this over symbolically is I would say that we draw these things, we call them rainbow lines or water bombing. And what this means is that I have 2 times 1 and I have 2 times 4, which is what I showed you on the picture with the other camera, right? So 2 times 1 is 2 and 2 times 4 is 8 and 2 plus 8 equals 10. So I get the same answer. All right. And we've seen this in the algebra project. I hope you've seen this in the algebra project where we're distributing, multiplying things. So this is the same thing. I have 2 b's and I have 2 4's. So I'm going to write this like this. So this equals 2 times b and 2 times 4. Now I don't need to, I can just put the 2 beside the b because that does mean multiply. I need to put something else over here because 2 beside 4 is 24, which is not what I want. I want 2 times 4. So I need either the dot or you could use an x. I would suggest moving away from the x just because it could look like an x variable. Brackets are good, okay? And then this equals 2b plus 8. Okay, and if I were to do that on the camera over here, I've got, oops, I need a pen that actually writes. So I've got a b plus 4 and another b plus 4, right? Okay, Okay, so I got a b plus 4 and another b plus 4, and I'm going to tear them apart, and I'm going to rearrange them. So I've got a b and I've got another b, so I've got two b's, and I've got a 4 and another 4, so it's 8. So 2b plus 8, which is what I got when I did it symbolically. All right. So now we're going to look at multiplying polynomials where you can't, like, how do I show 2x of something? Like, I can't do this on the camera because what does 2x of something look like? I don't know what x is, so I don't know how many pieces of paper I need. But because we're doing this symbolically now, I can just do the same thing. I can just do my rainbow lines, and this is 2x times 3x and 2x times minus 4. So when you're learning, I like you to put in that you have this, and you have that. Okay, so just continuing on, 2x times 3x is 6x squared, and 2x times negative 4 is negative 8x. Okay, now, when you've had some practice, it will look like this. You will have 2x times 3x minus 4, and you will just go in your head. It'll hopefully it won't be 2. It will be 6x squared minus 8x. And you will eventually get to where you can just do that in your head. But for now, I'd really like you to write it out this way at least a couple of times so you understand what it is you're doing. You have 2x of this thing and you have 2x of the other thing, and then you're multiplying each chunk individually, okay? And then remember that 6x squared and 8x are not like terms, so you can't combine those. I cannot make this any simpler than 6x squared minus 8x because they're not the same thing. I can't add them together at this point. Okay? All right, your turn. Go do this last question symbolically and then come back and check your answer. All right? How did you do? I hope you got that right. And then off you go, do the last assignment in your textbook, and then the quizzes and all of that stuff. Make sure you're marking your work as you go, please, please, please. Okay, have a great day. Bye.